Good day, everyone. My name is Rajesh. Today we are going to learn a case study on a real-time application on a topological sorting. First, we should know what is topological sorting. Topological sorting is a directed acyclic graph in a linear ordering of a vertices, where a directed acyclic graph means there is only a one way of direction, like this. There is only one way of a direction. There is no the end node will not reach again to the starting node. In for every directed graph, there is edges and vertices, and it is only possible for a directed acyclic graph without cycles. We have a multiple valid topological ordering for a same graph. This is some important applications for topological sorting. There are task scheduling and a project management, software building system, package management, and operating system. In a task building, in a task scheduling and a project management, only we can order the task based on the dependence to create a valid execution. And in a software building system, we determine the order of a completion of a source files with dependencies. Package management, resolving dependencies between packages during the installation. Operating system, managing process and preventing the deadlock in resource allocation. This is a algorithm for a topological sorting. There are two types of algorithm: DFS based algorithm, Kahn's algorithm. In the DFS algorithm, it uses a depth first search with a stack. In a Kahn's algorithm, it uses BFS first search. In DFS, it visits nodes recursively. In Kahn's algorithm, it finds nodes with a zero in degrees, and it pushes it pushes to stack after visiting all neighbors and a reverse stack for a final order. In a Kahn's algorithm, it removes them and their edges update in degrees and repeat the process. And example for operating system scheduling. In operating system, many processes have dependencies such as memory must be initialized before drivers can be loaded, and the drivers must be loaded before the scheduler can start. Services can be launched after drivers are loaded. There is a user log needs there needs user logging for both schedulers and services to running. Topological sorting ensures that the dependencies are satisfied in a correct order. And solution steps for a topological sorting. There are five solution steps. First, identify the nodes with a zero. Here we can see that where there is a node with a zero, we should first identify, then add this node to the result list. In second graph, we can see that where the first the node 1 is directed to 2, and where the first node is directed 2 and 1, which we had identified, we should remove that and update the list and update in degrees. Here in third graph we had updated the degrees, and repeat all nodes as process. Repeat until all the nodes get 0. Execute the task in order. The final sorted order is 1, 2, 3, 4. These are some real-time consideration and the benefits. that are predictable execution order, deadlock prevention, limitation, and adaptation. Conclusion. Conclusion, it is a powerful tool. Topological sorting provides a systematic approach to order tasks with the dependencies essential for complex systems. Critical for a structured execution. Ensures correct execution flow in operating system, preventing deadlocks and optimizing resource utilization. Limitation. Only applicable to directed graph, requires adaptation for a dynamic real-time environment with the changing dependencies.